Algebra 2 review lessons 1 through 20 for our quarterfinal. This is video 2. Let's see. So this class picked as their primary question, their first question was question number 15, which is a conversion question. Conversion really seems to be a dominant question type that's been picked off this test. It says we got 23 yards squared that we want to convert to inches squared, right? Okay. So the thing to remember about yards squared is that I always have to do the conversion twice, okay? Or square the conversion, either one. So if I'm doing 23 yards squared and I'm trying to convert, okay, then I'm going to convert from yards to feet, right? All right, so I'm going to put yards down here and feet down here. But if I'm going to put this at feet squared and yards squared, it's not 3 feet to 1 yard. It's 9 feet to 1 yard, okay? So from there, if I'm going to convert from feet squared to inches squared, it's not, 12 inches to 1 foot. It's 144 inches to 1 foot squared. Does that make sense? So we should wind up with a fairly large number. So we're going to do 23 times 9 times 144 all over 1. So really my number is just 23 times 9 times 144. All right, can we tell me what that is? 29,808. 08 inches squared. We've got an answer key at the back, so let's see if that comes out. Number 15. Give me a second. Yep, 29,808 inches squared. Do we understand how to do this now? Be careful, right? When you start seeing squared show up, you have to square the conversion factor. Okay. Next up on the list is number 4. So go back to first page. Okay. Word problems. Word problems do give people some fits. Car traveling at 60 miles per hour uses 3 gallons of fuel. The fuel tank has a capacity of 12 gallons. We're going to let T be the time in hours, X be the distance traveled, and Y the number of gallons remaining in the fuel tank. Write a parametric equation for X and Y in terms of T. I'm really surprised that this wasn't the leading question for either class. The other class didn't even put this on their list. Okay. They did? Am I missing it? Oh, there it is. It's way down there, right? Okay. So a car's traveling 60. Let's see if we can kind of common sense this. Okay. We're going 60 miles per hour. We're using 3 gallons of fuel. A car traveling 60 miles per hour uses 3 gallons of fuel. Okay, so it takes 3 gallons to go 60 miles per hour. Okay? Okay, the fuel tank has a capacity of 12 gallons. So let's kind of think about some things as we go along here. If we're traveling 60 miles per hour, and in that time, let's say that we're traveling 1 hour, right? 60 miles per hour, we're traveling 1 hour, we're going to burn 3 gallons, correct? All right, how many hours could I drive at that rate? I could because I have 12 gallons, so I'm going to take 12 divided by 3, right? That's going to tell me how many hours I can drive, right? So I can go 4 hours before I run out of gas. Is that correct? Okay. And if I can go 4 hours and I'm going 60 miles per hour, how far could I travel in that amount of time? I could go 240 miles, right? So all this makes sense so far. All right, it says let T be the time in hours, let X be the distance traveled, let Y be the number of gallons remaining in the fuel tank. Write a parametric equation for X and Y in terms of t. So in terms of t, if I don't have this wrong, okay, usually means that t equals. Okay, so they're starting off here with, let's write down what our variables are supposed to equal. X is distance. Okay. T is time. Okay. Y is gallons. Okay. Gallons remaining in the fuel tank. Okay. So what I want you to understand is that one of our equations that we use is distance equals rate times time. Okay? So if I substitute d out with x, x equals, and what is my rate? Rate is typically speed. What is my speed? 60. Okay? All right, so how far we can go is determined by my rate times my time. They haven't told us how long we're traveling for, have they? All right, so x equals 60t. So in this, y, if we want an equation for y equals, okay, how many gallons do we have? 12. Okay, because what we want to find out is really kind of how far we could go. We have 12 gallons minus our, let's see, we've already used 3 gallons. We're using 3 gallons per 60 miles per hour. So that's 3 times t. It's going to tell me how many gallons I will have left based upon how many hours I'm driving. Okay, so our answer for this comes out to this, but do we understand the process? Yes or no? Yeah, no. Okay. Do we understand x equals 60t? Okay, so we got that part. It's the y minus 3t that we don't like. Is that correct? Okay. Let's see if we changed it a little bit, and it would probably be something that I would accept. All right, so we have y. Y is our number of gallons, right? Okay, we want to be able to figure out, because we said up here, what did we figure out? I guess we didn't really solve for gallons. We did find out how far we could go on those gallons. Okay, so we want to know, at any given number of hours, how many gallons we're going to have in our tank, right? We know that we're starting with 12 gallons, correct? I have to have a starting point. I have to know how many gallons I have. Y is never going to be more than 12, correct? So for instance, if I said, y equals 12 gallons minus, I'm burning 3 gallons per hour, but I haven't started driving yet, right? So the number of gallons in a tank at 0 hours is 12, right? But if I drive for 1 hour, right? Well, that's going to be 3 gallons. I'm going to subtract those 3 gallons from the 12, right? Okay, so now I'm down to 9 gallons. So are we starting to understand the equation a little bit better now? Okay, so we're using that to find out how many gallons we're going to have based upon how much time I'm traveling. So, granted, like I said, I would probably accept something like this where we had negative 3t plus 12. That's the y-intercept form of the equation, but I think that for our purposes, this actually makes a little bit more sense. Okay, do we follow that at all? Are we a little less iffy on that than we were 20 seconds ago? Okay, or you just want to move on? Okay. All right, number 6. Number 6. Okay. Determine the kind of variation presented by this data. Find the constant of variation in the equation. Okay, so I'm not going to rewrite the chart up here because that'll take too much time, but the x values are 2, 3, 4, and 5. As we go along that chart, are x values increasing or decreasing? Increasing. All right, my y values are 9, 13.5, 18, and 22.5. Are those numbers increasing or decreasing? Increasing. So it's increasing, increasing. So is this going to be direct or inverse? Direct. So can anybody tell me what the equation for direct variation is? Y equals kx. All right. Now, in order to determine if this is a direct variation in here, I have to solve for what? Am I solving for x, y, or k? K. How do I solve for k in the equation y equals kx? Divide by x on both sides, right? So that means k equals y divided by x. So in this, I'm getting 2 divided by 9. Well, that's 2/9, right? Okay. Now I have 3 divided by 13.5, right? Well, what is that? Does it come out as the same thing as 2/9? Oh, yeah, you're right. 9/2. All right, sorry about that. 9 divided by 2, which is 4.5, right? Okay. All right, is 13.5 divided by 3 4.5? Okay. Is 18 divided by 4 4.5? Yes. Is 22.5 divided by 5 4.5? All right, so my k is 4.5. All right, so we're going to say direct variation, okay, and my constant is 4.5. Does that make sense? Great. Let's see, number 11. Use Kramer's rule to solve. We have negative 7x minus 3y equals negative 8. 6x minus y equals negative 5. If they ever give you this and your x's and y's are flipped from each other, right? So I've got x, y solution, and then it goes y, x solution. Do I need to change one of those? Yeah, I do. Because if I'm solving using Kramer's rule, right, and I'm using x, I'm doing x first, then I'm subbing in negative 8 and 5, or negative 8 and negative 5 in for the x values. But if I have, an x here and a y here, that doesn't work, right? Okay. So what goes on the left-hand side of my determinant for my x? Negative 8, negative 5. I sub in for the x values. What goes on the right? Negative 1. Okay. And in the bottom on the left? Negative 7, 6. Perfect. You guys are rocking and rolling. All right. So how do I find a determinant in the numerator? Minus negative 5 times negative 3, right? It's a whole lot of negatives in there. Okay. Negative 8 times negative 1 is 8. Negative 5 times negative 3 is 15. So I'm winding up with 8 minus 15, which is negative 7, right? Okay, cool. All right, negative 7 times negative 1 is 7 minus what? Minus negative 18 plus 25, negative 7/25. That seems a little crazy, but maybe it's the answer for our x value on number 11. I got to go another page over. Yeah, that works. All right, now we have to do y. Okay. All right. So do we need to do anything with the denominator here? No, we just know that's 25. All right, so we're going to do negative 7, 6, and what? Okay, we know that's 25. All right, negative 7 times negative 8 is 35 minus, what's 6 times negative 8? Negative 48. Right, 25. What's 35 plus 48? 83. Ooh, 83/25. I don't know if that'll reduce or not. Seems like a wild one. And our answer is 83/25. So finally, what we want to do is put those in coordinate notation. That is the answer. Okay, we reminded of Kramer's rule now? Okay, hopefully we can do that come test day. All right, after 11 came 21. Oh, gosh. Okay, it says given, this is the last question on the list, right? No? No. I know not on your list, but it's the last question on the test. Given f of x equals 2x plus 8, our domain is real values, okay? And g of x is negative 8x minus 7, which is using integers, all right? So no fractions, no decimals, nothing like that. Find the algebraic difference, f minus g of x. So it's because it's f first, we have 2x plus 8 minus negative 8x minus 7. Okay, what do I need to do first? Distribute the negative there and there. So I got 2x plus 8, what? Plus 8x plus 7. Now what? 10x, right? 2x and 8x plus 15. And it just wants the algebraic difference. So as far as I can tell, that is probably it. Let's see, checking our answer key. That is it. That's our answer. All right, are we feeling a little bit better about this test? Maybe? 20? 20. All right. Same type of thing. Well, I mean, in the ballpark, but different. All right, we want f of g of negative 4. Well, f is x plus 9, and g is x minus 4. Now, we do have an option. We can go ahead and FOIL this and then plug in 4 at the back end. Or we can plug in 4 at the beginning. Which would we rather do? Plug in 4 at the beginning is a good choice. 4 plus 9 times 4 minus 4. Well, at the moment I see this, I already know my answer is what? Oh, did I miss something? Oh, you're right, negative 4. Okay, it would have been really quick to. Oh, yep, it should be. All right. Did I mention I have a pounding headache? Can I get a little bit of sympathy for that? Negative 4. Okay, so I got 5 and negative 8. So my answer is negative 40, right? Negative 40. All right. Oh. All right, this kind of goes back to the rules, though. Because they wanted us to plug in negative 4. All right, go back and look in number 20. It says for g of x, it has to be positive integers. Is negative 4 a positive integer? No. So because negative 4 isn't a positive integer, by the rules, we can't solve. No solution. Okay? So you do have to look at the rules that they give you. All right. Yeah, it says the common domain is positive integers, therefore f of g negative 4 cannot be found. All right, after 20 came 8. Says calculate the slope of the line that contains the following pairs of points. Tell whether the line rises, falls, or is horizontal or vertical. All right, so what's our formula for finding slope? Y sub 2 minus y sub 1 over. Okay, very good. All right, my coordinates are 2, 0, and 6, negative 2. So what number goes in for y2? How about I give you those again? 2, 0, and 6, negative 2. Negative 2. Negative 2 minus what? 0 over 6 minus 2. All right, what do I get in my numerator? Negative 2. What do I get in my denominator? 4. I love how everybody's like, Absolutely bored. 4. Everybody together in unison. 4. This is lame. All right, so my answer is what? Yes, I love that. Like when everybody says the same thing, really monotone. Like it makes me feel like I'm a cult leader, and that's just a really cool feeling overall. So. Thank you guys for the unenthusiastic, monotone chant type answer that you're giving me. All right, after 8 is 10. Okay. It says solve the system by graphing. I always feel like I've done this one. Oh, it's one that we got into, but we didn't finish in the other class, I think. So it starts off with 7y plus 3x equals 16. And then it gets me negative 2y plus 3x equals 7. Now, the way we started to do this in the other class is we converted both equations over to slope-intercept form so that we could graph them. Right, that's one way to do it. Another thing that you could do is you could plug, like for the first equation, you could plug in 0 for x and get your y-intercept. You could plug in 0 for y and get your x-intercept and graph those lines. Right, it's going to give you the coordinate pairs for where it's going to cross the x and y axis, and you draw both lines here where they cross. Does that make sense? So we have all kinds of possibilities. We could subtract these two equations and solve for y, right? Because 3x and 3x are going to cancel out if I subtract the two of them. Let's see if, and I'm not a huge fan of converting these to slope-intercept form just because what you're going to get is going to be kind of goofy. For instance, we're going to get 7y equals negative 3x plus 16 divided by 7 across here. So we're going to get y equals negative 3/7 x plus 16/7. The reason I don't like that is because I'm going to have to graph on a line for the y-intercept 16/7. Right? That's not going to come out to anything nice, neat, or organized. So I know that it says solve it by graphing, but in the end, what do we really need to do? We need to solve it, right? So this is what I'm going to do. I'm going to subtract, right? I'm going to cancel out the x's. 7 minus negative 2 is what? 9y. Do you guys know what mistake you made? I heard a whole bunch of 5s in there, right? We were subtracting a negative. All right, what's 16 minus 7? 9. So y equals 1. Now that I have that, I can do 7 times 1 plus 3x equals 16. All right, subtract 7 from 16, 3x equals 9, x equals 3. So where do these lines cross at? They cross at 3, 1, right? And I don't even have to have some weird y-intercept. And because once you have some weird y-intercept, how can you accurately graph, down 3 over 2? You see what I'm saying? Yeah. Because we solved for y equals 1, we plugged in 1 into the first equation, right? 7 times 1 is 7. We subtracted 7 from 16, got 9. 9 divided by 3 is 3. Does that make sense? Cool. All right. So ultimately, if I had a whole bunch of graphs and I didn't want to go about actually graphing it, this is all recorded, I guess you can hear it. But chances are every one of those is going to have different solutions, right? I'm going to go with the solution that has 3, 1. Okay. After that, we had what, 19? How are we doing on time? Not great. 19. This is like advanced foiling. I'll see if I can get through it. A minus 2 times 2a squared plus 7a minus 2. All right, so I'm going to start off by distributing the a. You're right. Yeah, a minus 3. Okay, so 2a cubed plus 7a squared minus 2a. And then go and distribute your negative 3. Okay, right, you guys will be fine, right? We'll stop there. You guys don't have your test till Thursday, so we can cover a lot more of these questions if you feel like we need to.